Hello, in this video I'm going to demonstrate the embedded modeling functionality within the SMARTree client. So beyond just creating smart trees of material and processes and whatnot, you can also, as I mentioned, use the client to actually run models directly off of the trees. So the model I'm going to show in this tutorial is the classical laminated plate theory model. And that model is available both as example models and as a template. So there's a template in here as well, model template. And all of these models and their associated templates are available on the GitLab site, and access to those and getting access to those is explained in an earlier video. So to run this model, you basically just have to fire up the software, and when you start the software looks through all the smart tags, and the smart tags are then organized so that it knows what every smart tree is. So it identifies all the material smart trees, all the model smart trees. It also finds all the model templates and uses those templates to establish what are the operating models inside the SMARTree client. So before I operate the model, I just want to show you what's going on in the back end. So in the back end, I like to pull up this schematic. It basically describes how all these smart trees talk to one another. So what we're going to show in a moment is the model smart tree of a classical laminated theory model. And within that model, there is a laminate, and that laminate is comprised of materials. These materials are stored in separate smart trees. These materials have properties. We use a property smart tag to be able to get associativity between the properties within a material that are used in the model. And we also have a units smart tree to establish the units within those properties. So all of this is going on in the back end and is basically used as a kind of a bookkeeping resource for you to simply just run the model, and it will hunt down and grab all the material information needed to run that model. So let's go ahead and run a model, and this is the one loaded right here. If you want to load another model, you can just clear this out and just drag in whatever model you want to run. And as I said, in this particular instance, we're going to load our thin plate model, which is this one right here. And basically the model is comprised of a number of different sections. We have essentially the top section right here is kind of our header. It describes what the model is and if there's any references, and it uses this identifier, which is a 3-letter code that lets the client know that what this model actually is. So in the back end, it actually runs the solver engine associated with this 3-letter code, and that is hard-coded into the client. The next part of this is the model inputs. So in here we have 3 laminates. You can click on the laminates and you can see down below in the element viewer what these laminates are. And then we have loading conditions for those laminates or laminate. And then finally we have model outputs. So the model outputs, there's a long list here, but what it does is it predicts the effective properties, both the mechanical properties and thermal properties, and it also predicts the stresses and strains and displacements and curvature, and the ABD matrix as well. So all of that information, if you're familiar with laminate mechanics, this is all fairly familiar information. Some of these already have plots already created, but you can actually create very simply by using the add button. You can add a plot to all of the results. Right now these are all tables. There's a couple of them that have plots, and that's pre-built in the GitLab shared resource for people to use. So in order to run the model, you simply go to the model tab on top, and you then select the appropriate model. So in this case, we're going to run the classical laminated plate model. And so what it does here, it's all kind of color coded. So the inputs are in green, the outputs, in this case effective properties, are in blue, showing the output that it's going to be, and the result of that output is in light blue, and the associated units are also highlighted. So so that's where the relationship is established. As I said, we use other trees to formulate what are inputs, what are outputs, what are properties, and what are units, and that's all done in the background. This little model status window down below on the bottom left shows you that it found the material for this particular laminate. So we're actually looking at this one right here, and it found orthotropic properties. So this is a little status update to tell you that it's finding the properties needed to run the model. If the properties are missing or 0, it will warn you here saying there's some properties not quite right. You need to go back into the material and fix those. So right now everything looks fine, and it's found that particular ply information. So if you want to look at the results, you can simply, in terms of the stresses, you can just click on a plot and it shows a plot of this. You can go back up here and you can actually vary the load, you can vary the in-plane load, and it's all live, as I said, so you can vary the moments and you'll see the moments flip. You can go in here and you can edit your laminate, and you know, you can add more plies. Just use the plus button, you can add plies. You can change the layups fairly easily into like a quasi laminate. You can actually hit the symmetry button, it makes it all symmetric. You can actually fill down, so if you have you know, if you want to change any value, whether it be a material or a ply thickness, you can do that as well. The other noteworthy fact here is the smart tag concept allows you to pick from all our smart tags what material you would like to have in there. So if I click on lamina, it digs through all my smart tags, and these are described with smart tags as laminates. If I wanted to put another different material in there, I could say, okay, let's sift through all my metals, and it will find whatever metals I have over here, and I basically put that in there as well. And you can change out any one of these and it will populate the results immediately. If you want to look at different laminates, the way to do that is you can double click the laminate, and now it's solving for this second material right here. It says it found those properties, and once again you can plot the results like so. You can double click a plot, it will open the plot in a new window. That allows you to basically go back into your laminate down here, and you can actually change the layup or the, you know, the information about the ply, and it will update the result basically in real time as well. So there's a lot of options in here in terms of how you manipulate your laminates. You can copy and paste right here. Copy, you can paste a new laminate, paste all. So you can make copies of laminates and you can edit those as needed, and you can there's a lot of features right here for you to be able to manipulate those laminates and basically look at the results in real time. So that's basically how how this software runs a simple laminated solution. Once you're done, you can save your result. You can also create a report as well. So thank you.